Good afternoon. Today I thought we would work the review for test 1 for my Math 13-14 class. All are getting ready for a test. Maybe it'd be a good time to work this review. And here we are, starting at number 1. The square root of negative 45. Let me switch there. The square root of negative 45. Well, this is a pretty short one. 45 is not a perfect square, but what's the largest perfect square that divides evenly into 45? Okay, you think of it as negative 9 times 5. 9 is the largest perfect square that divides evenly into 45. Since it's negative, you know the square root of 9 is 3. Because it's negative, we bring up that imaginary unit I. What are we going to do with the 5? We leave it under the radical, correct. So the square root of negative 45 can be reduced to 3i square roots of 5 using imaginary numbers. So we type in 3i, we need a square root, and under that square root symbol we put a 5. Okay, next question. Write in standard form. This is number 2. Negative 10 plus the square root of negative 40 all over 2. Make sure I didn't miscopy that. Negative 10, yes. Everything I do today, I've been miscopying stuff, so let me be careful. Make sure I didn't miscopy it. When you see that square root of a negative, you know you're going to have to write it using the imaginary unit I. Maybe we should just do that first. Let's just write that as I square roots of 40 all over 2. And now that square root of 40, is 40 a perfect square? No. What's the largest perfect square that divides evenly into 40? It should be pretty obvious. A 4, I agree. So here's how we're thinking of that. We're thinking of that square root of 4 as 4 times 10. So we have, I'm going to carry down negative 10 plus the square root of 4 is what? 2. So we have a 2. Don't forget that I. What are we going to do with that 10? The 10 stays under the square root. I agree. All over 2. The square root of 40, the square root of 4 is 2. The square root of 10 stays under the radical. And then we can split up negative 10 over 2 plus 2i square roots of 10 over 2. Negative 10 divided by 2 is negative 5 plus, cancel the 2's, and we have I square roots of 10. So negative 5 plus I square roots of 10. A word of warning, as we said in class, you cannot just start canceling at this stage. You can't cancel over addition or subtraction. I guess we could have factored a 2 and canceled at that point, but I think the most popular way is just split up. Negative 10 over 2 plus 2i square roots of 10 over 2. Giving us a final answer of negative 5 plus 2i Go to the square root key in your toolbar. Oh wait, not the 2. The 2 canceled, did it? Thanks for pointing that out to me. Is that what I wanted to write? Type? Yeah, I think it is. Question number 3. We have, it says subtract and simplify. We have the complex number -5 plus 7i minus the complex number -8 minus 8i. We said during class that operations on complex numbers were very similar to operations on variable expressions. If those i's were just variables, you'd look and say, oh, that first set of parentheses is unnecessary. There's nothing to distribute. So we just drop it to -5 plus 7i. But the second set of parentheses is preceded by a minus. What do we do to get rid of the parentheses when there's a minus in front? Okay, you're distributing. That's changing the signs. It's like multiplying by -1. So that minus a -8, that becomes a +8. Minus a -8i becomes a +8i. And then we can combine the real parts. -5 plus 8 is a +3. And what are we going to have with the i's? 7i plus 8i. I agree, that's a +15i. So our final answer is 3 plus 15i. Three plus 15. Don't forget your I. Any questions there? Okay, number 4. Here they want us to multiply complex numbers. We're multiplying 7 plus 6i times 9 minus 4i. Seven plus 6i. As I said, the algebra for complex numbers is very similar to just the algebra involving variables. This looks like a binomial times a binomial. Binomial times a binomial. We multiply. What's that little nickname we give this process? 4-letter word beginning with an F? FOIL. That's right. First, 7 times 9 is 63. Outer. I agree. -28i. Inner. 6i times 9. That's a plus. 54i. I agree. Last times last. +6 times -4 is a -24. But I times I becomes I squared. What's that last term going to change to? I squared is equal to -1 times a -24. So this last term is actually a +24. Combining the real parts, the thing that don't have i's. 63 plus 24, that's an 87. -28i plus 54i, is that a plus 26i? -28 plus 54 for a final answer of 87 plus 26i. 87 plus 26i. 87 plus 26i. Any questions there? Okay. Number 5. Oh, simplify, write your answer in the form a plus bi. Uh-oh, it looks like we're dividing complex numbers. Let me write the problem down. 4 plus I all over negative 3 minus 2i. 4 plus I divided by negative 3 minus 2i. Switch back to my paper. This is the complex number 4 plus I. It's being divided by the complex number negative 3 minus 2i. Remember, our goal is to have no i's in the denominator, so the trick is to multiply above and below by the conjugate of the denominator. That means just change that connecting sign. So instead of a negative 3 minus 2i, we're going to have a negative 3 plus 2i. And so this is really repeated foiling here. We're going to have to FOIL the numerator, FOIL out the denominator. So FOILing out the numerator. First, 4 times negative 3 is a negative 12. Outer, 4 plus 2i, that's a plus 8i. Inner, I times a negative 3 is a negative 3i. Last, I times 2i becomes a plus 2i squared. Now do the same thing for the denominator. Negative 3 times negative 3, that's a positive 9. That was first. Outer is a negative 6i. What's the inner going to be? Negative 3i times negative 2i times negative 3. Negative times negative, that's going to become a plus 6i. Last, negative 2i times positive 2i. That's a negative 4. I times I is I squared. And remember what happens to the I squares. What's that plus 2I squared going to become? I agree, it's going to become a minus 2. I squared is equal to negative 1 times 2 becomes a minus 2. What's this thing going to become? A negative 4 times negative 1. A positive 4. In the denominator, remember our goal is to have no i's left over in the denominator. I think we've done it. Negative 6i plus 6i, what's happening there? They're subtracting out. So we have a 9 plus 4, that's 13. We have a negative 12 minus 2, that's a negative 14. 8i minus 3i, that's a positive 5i. And then we split up. To get it in a plus or minus bi form, it's negative 14 over 13 plus 5 over 13, and we'll stick the I out beside it. I think if you leave the I on top, my math lab will take it also, but any questions there? The trick is to change the sign of the denominator and multiply above and below by that. If you do it correctly, all the i's should disappear, and then you can split up over that new denominator. So, going back to my lab, I have the answer, negative 14 over 13, right arrow, plus, we have the fraction 5 over 13, right arrow, and check answer. Any questions there? Okay, number 6. Oh, that's interesting. Match the following equation with its solutions. Well, I think we'll just solve this equation. X squared is equal to 18. This equation is tailor-made for the square root method. The square root method can be used when you have a quantity squared on one side and a number by itself on the other side. If you're going to use the square root method, you drop the square on the left, and what do you pick up on the right? It's more than just a square root, a plus or minus, right? A plus or minus square root of 18. I have a question. Is my answer going to contain an I? No, because the thing under the radical, it's not negative, so it's not going to contain an I. Is 18 a perfect square? No. What's the largest perfect square that divides evenly into 18? 9, so here's how you're thinking of it. 9 times 2. The square root of 9 is 3, but what do we do with the 2? You leave it under the radical. So plus or minus 3 square roots of 2 is our final answer. Oh, wait a minute, this is multiple choice, isn't it? So we have to type it in. I think it's A, isn't it? Plus or minus 3 square roots of 2. Number 7. It's another square root property problem. This is number 7. These problems like this are nice. They're not making you type the stuff in. It's just multiple choice. So we have the quantity 3x minus 4 squared equals 30. Here it is. You can use the square root method as long as you have a quantity squared equals a number. And that's what we have. So we drop the square on the left. So we just have a 3x minus 4. But we pick up, on the right-hand side, we pick up a positive or negative square root of 30. Is 30 a perfect square? No, so what's the largest perfect square that divides evenly into 30? Is there one other than 1? 6 times 5, neither of them are perfect squares. 3 times 10? No. Can we simplify the square root of 30? No. Well, let's solve for x then. I'd move that 4 over by adding, so we have a 4 plus or minus the square root of 30. And then, to get the x by itself, we divide to give us x equals 4 plus or minus the square root of 30 all over 3. Now, if this were imaginary, if there were an I would definitely split it up the way we did here. But there's no I, so I bet you this is what they have for us. Remember, it was multiple choice. 4 plus or minus the square root of 30 all over 3. Is that it, the first one? 4 plus or minus the square root of 30 over 3? I think that's it. Number 8. Use the quadratic formula to solve the equation. Here's the equation. 2x squared minus 7x is equal to 1. 2x squared minus 7x. If we're going to use the quadratic formula, we need the equation set equal to 0. I prefer the leading coefficient to be positive. So the only sensible thing to do to get it set equal to 0 and keep that leading coefficient positive, I see someone doing this with their hand. Yes, they move the 1 over. So you then have 2x squared minus 7x minus 1 is equal to 0. We call the quadratic formula negative b plus or minus the square root of b squared minus 4ac all over 2a. Let's identify a, b, and c. A is the number in front of x squared, so 2. What's b? Not just 7, negative 7. B is negative 7, and C, negative 1. Be sure to take those signs. So, we're going to plug into the quadratic formula. So, the opposite of B, the opposite of negative 7, you're changing the sign on negative 7 to get a positive 7. B squared, 7 times 7 is, I should say negative 7 times negative 7 is positive 49. And then minus 4 times A times C. Minus 4 times A times C. Remember we said A was 2, C was negative 1. And what's going to go here in the denominator? 2 times A is a 2. Let's work underneath that square root. That thing under the square root is called the discriminant. We're going to have, that's a 49. What's a minus 4 times 2 times a negative 1? That's a negative 8 times negative 1, so that's a positive 8. I agree. So you have 7 plus or minus the square root of 49 plus 8 all over in the denominator. 2 times 2 is 4. 49 plus 8 is a 57. No, all over 4. Pardon me, that denominator is a 4. 49 plus 8 is 57. Is 57 a perfect square? No. Are there any perfect square factors that divide evenly into 57? No. I think this is it. I think this is what we're going to enter. The square root of 57 can't be reduced. 7 plus or minus the square root of 57 all over 4. So we come over here. What's the first thing I should do? What should I type first? The fraction bar. And on top I have a 7 plus the square root of 57. And on the bottom I have a 4. Oh, wait a minute. It's a 7. What am I doing? What should I have had there? A plus or minus. A plus or minus hot button. Any questions there? I like it when when that thing can't be reduced, because then you're through with the problem. Any questions? Okay, number 9. Oh, it's another quadratic formula problem. Let me write it down. X squared plus 2x minus 4 is equal to 0. Once again, we're using the quadratic formula. Okay. We're using the quadratic formula. Are we going to have to move terms around on number 9, the way we did number 8? No, because the equation's already in the desired form. We already have it set equal to 0. Notice up here the constant was on the right. We had to move it over to the left. We recall the quadratic formula. Let's identify A, B, and C. A is equal to, no, it's not x squared, it's the number in front of x squared. You don't see a coefficient, you assume a positive 1. B is equal to positive 2, C, a negative 4. So, substituting into the quadratic formula, the negative of b, the negative of b, the negative of positive 2 is a negative 2. B squared, 2 times 2 is 2 times 2 is 4, I agree, minus 4 times A times C. A is a 1 and C is a negative 4, all over what's in my denominator? 2 times here, 2 times 1, I agree. So we have a negative 2 plus or minus. What are we going to have under that radical? Negative 4 times 1 is a negative 4 times a negative 4. Isn't that a 4 plus 16? All over 2 times 1 is 2. And 4 plus 16 is 20. So we have a negative 2 plus or minus the square root of 20 all over 2. 20. Is 20 a perfect square? No. What's the largest perfect square that divides evenly into 20? So you're thinking of it as 4 times 5. The square root of 20, you're thinking of it as 4 times 5. And that's a negative 2 plus or minus. The square root of 4 is, the square root of 4 is 2. What are we going to do with that 5? The square root of 4 became a 2. The 5 stays under the radical all over 2. And then we have a choice. We can either factor and cancel or split up. I think I'm going to factor and cancel, just because we haven't done that today. 2, we have a negative 2 and a positive 2. Those things are both negative 2 and positive 2. They're both divisible by 2, so I'm going to factor out a 2. Negative 2 divided by 2 gives me a negative 1, plus or minus. 2 square roots of 5 divided by 2. What are we going to have left here? 2 square roots of 5 divided by 2 leaves us 1 square root of 5. And then you can cancel the 2's to our final answer, negative 1 plus or minus the square root of 5. For my final answer. You could have split up right here. Negative 2 divided by 2 is a negative 1. 2 square roots of 5 divided by 2. You cancel the 2, leaves you a square root of 5. So either way you would have gotten the same answer. Let's punch this into my lab. It's a negative 1 plus or minus the square root of 5. Number 10. Oh, it's another quadratic formula problem. I guess that means I think this is pretty important. What do you think? On number 10, you're going to solve using the quadratic formula. 14x squared plus 14x is equal to 5. Okay. There's only one sensible first step. What is it? Okay, get it set equal to 0. Move that 5 over, so you have 14x squared plus 14x minus 5 equals 0. We call the quadratic formula negative b plus minus the square root of b squared minus 4ac all over 2a. And, let's identify a, b, and c. Let's identify a, b, and c. What would we say a is? A is a positive 14. What's b? Oh, it's a positive 14 also. And c, a negative 5. I agree. So, let's start substituting into the quadratic formula. Negative b, the opposite of positive 14, is a negative 14. We have a b squared, so that's a 14 squared minus 4 times 14. A is 14. C, negative 5. Where's my calculator? Maybe I'll use my calculator on this one. Okay, wait a minute, I'm not through yet. What's the denominator? 2 times a, 2 times 14 is 28, I agree. Let's work underneath that square root. We have a 14 squared minus 4 times 14 times negative 5. That's giving me a 476. So we have a negative 14 plus or minus the square root of 476 all divided by 28. Oh, let's see. Is 476 a perfect square? What do y'all think? I don't think so. No, it's not a perfect square. Well, let's see. What's the largest perfect square that divides evenly into 476? 476, let's see. Well, it's divisible by 3. If my mental arithmetic, no, it isn't, is it? 476 isn't divisible by 3. How about, let's see, the square root of 476. Thinking about your perfect square. Let's see. Let me see something. If I divide it by 2, is that going to give me a perfect square? Is 238 a perfect square? I don't think so. I think 4. I think that's all we're going to be able to do. 4 times 190. Let's see, 476 divided by 4. I think it's going to be a 4 times 119. Okay, so I'm thinking of 476. I'm thinking of it as 4 times 119. So we have a negative 14 plus or minus. The square root of 4 is 2. The 119 stays under the radical. And down here we still have a 28. Let's factor and cancel again. 2 and 14, they're both divisible by 2, so we're going to factor out a 2. I'm taking out a 2. What am I going to be left with inside those parentheses? Negative 14 divided by 2 is negative 7, plus or minus. 2 square roots of 119 divided by 2, you took out the 2. All you have left is the square root of 119. And then you can say 2 goes into 28 14 times. So I'm getting negative 7 plus or minus the square root of 119 all over. In the denominator, I have a 14. What a strange looking answer. Watch me have messed up and y'all just sat there and didn't say anything. Would y'all do that? Yes, y'all would. Y'all just sit there when I mess up. I can't blame you. I would have done that the same thing if I was a student. I would sit out there if I spotted a student, a teacher making a mistake. I'd just sit out there and let them keep compounding it. But no, that was right. It was a strange looking answer, that's for sure. Any questions there? Okay, we've done the first 10 problems here on the review. Let's take a little break, okay? I need to get myself a drink because I'm talking so much. So we'll